All right, so this is one of the uses of the auxiliary contact. In the previous video, when we on the contactor, it energizes, but as soon as we remove our hand from the push button, it de-energizes. So there is a way to keep it energized. It's called latching. When you press your start button and it remains in its energized state, just like on your machine. When you press start on your machine and the machine keeps moving even after you have removed your hand from the start button. So we are going to demonstrate this using this is one of the uses of the auxiliary contact. So what I've done here is still the same setup as what I have before. The positive terminal of my battery, of my power supply, comes to a stop button, a normally closed contact. It comes out here to the start button. Then from that terminal of the start button, I connect the normally open contact of the contactor here, then from the other end to the A1. So it's just like I am connecting the normally open contact in parallel with my start button, such that once I start the contactor, it gets energized. Once I start it, this A1 comes out here, this supply comes out here to the A1. The coil of the contactor gets energized and this contact become closed. This normally open contact will close. So at this point, the contactor has two sources of supply to its coil, through the push button and through the normally open contact. So when I remove my hand from the push button, because this is already closed, so it keeps sending 24 volts to the coil of the contactor. It keeps it energized. So that's how it works. So let's demonstrate this. So as it is now, let me, this is it. You see that after removing my hand, it's still energized. So this is called latching. I've latched the contactor. So whatever I connect to this contactor, assuming this contactor is running a motor, the motor keeps running. So this is what I'm explaining. As at this point, the contactor is energized through this push button here, this start button. You can see the 24 volts from here. It comes out here to the A1. Then you can see another 24 volts that goes through the normally open contact to the A1. So it has two, it's been energized through two sources now. So if I remove this one, because this one is already closed, it's a normally open contact, it's already closed, so it keeps the contactor energized because the 24 volts keeps flowing to the A1. So that's how it works. So it keeps running till I engage the stop button, then it stops. Start again, then it stops. So this is one of the uses of the auxiliary contact of a contactor. Okay, this is another use of the auxiliary contact. You know, on our panels we have status indicators. We have some lights on the cover of our panel. So we want to see that, assuming this is powering a motor, if the motor is running, we want to see an indicator that shows us running. A light will come up on the panel that will tell us that this motor is running. So now it's still the same design. What I've done here is, on the normally open contact here, I've added a lamp. So you can see the positive from the normally open contact, it comes here, then the negative goes to A2 for the lamps to come up. So as soon as I start my contactor, you can see the lamp comes up. So if this contactor was running a motor, the motor will keep running. This is an indicator for me that is running. So when it goes off, I will know that my motor has stopped running. So you can see I'm not pressing the start button and the contactor keeps energized. It will remain like this until I press my stop button that stops both the contactor and the lamp. So this is just another use of the auxiliary contact to show us that we want to use it, that whenever the contactor is energized, we want something else to be happening, which is this lamp that comes up. So you can see like this is running until press the stop button.